Okay, so hello from my side. Let me share my screen. Okay, so should now see my presentation and hear me? Everything fine? Perfect. Okay, so hello everyone. I would like to give you a short introduction into containers and Kubernetes and how you can use them on Azure. So talking a little bit about the basics and then going over into how Azure can help you running them. Okay, so short introduction of mine. I am Nico Meisenzahl. I'm working for White Duck. We're a company based on Rosenheim, south of Munich. Yeah, I'm working as a cloud consultant. I'm Microsoft MVP, Docker community leader, and GitLab hero. And I'm working with our customers and mostly doing Kubernetes, helping them with DevOps and other cloud topics. So my agenda for today. So first of all, I would like to speak a little bit about why we need Kubernetes or when Kubernetes is needed, and then heading into how Kubernetes works. So giving some introduction about Kubernetes and bringing it to a baseline also for the talks after mine. And then I will head over how Azure can help you. So doing a demo and talking about Azure Kubernetes Service, Azure Container Registry, Azure Container Instances, and ending this up with a short demo. Okay, so why do we need Kubernetes? So let's briefly talk about where containers can help or why we need containers. So containers, first of all, can help us with isolating our processes. So they help us to run multiple applications or multiple services next to each other on one node without any dependencies between them. So you can just run your instance and the instance itself doesn't care about any other instance or any other process application next to it, which is pretty nice. So you can isolate your processes and only provide them the stuff they need. Then with isolation, the next one is dependencies. So with containers, we have the option, or with container images, you have the options to change the underlying file system of a process. So with this, you are able to really put all dependencies your process needs. Now let's talk about a Node.js application. You can put in Node.js under it, or if you like to build an application in a container, you can put in some SDKs or other stuff. So you have the option to really put in the layer your application needs and to make sure that the dependencies are met. And then we have scalability. This is basically an option to scale out containers. Of course, the application itself needs to support this or needs to allow this. But if the application allows it, you can easily scale out your applications on one node or on multiple nodes because of having the isolation between the instances. And the fourth and last thing is immutability, which basically means every time a container starts, it starts from the container image you provide. So every instance of this process or of this container is looking the same all the time. So you're defining your Docker container or your Docker image with a Docker file, you're putting in all the dependencies, and with this, you are able to have immutable and same looking container instance every time you're starting a container. And with this, you can also restart a container without losing any changes and so on, or at least losing any dependencies, because you're starting a new instance and it will look the same. Okay, but with container, we are not yet production ready. So there are some things we will need to run containers in productions, and with just running containers or just using Docker as we know it will not provide with us. So some of them are around managing, around scaling, and around monitoring your applications, and to better run them in production. So examples, you maybe would like to scale containers across multiple nodes. So thinking of you're running Docker or Docker Compose, you're limited to one node. So if this node doesn't allow you to provide you with enough compute or resources, you need to scale out by adding more nodes. Or if you would like to have you're sure that your instance or your container is running all the time, you might need to add multiple nodes to have any kind of high availability. So with just using Docker plain or Docker Compose, this wouldn't work. Then you need somehow service discovery and load balancing. Thinking about you're scaling out your application, you're running 5 instances, 10 instances, 20 instances of your application. You need a piece which helps you to do load balancing between those instances. And you also need a piece which allows you to talk between the services. So think about you have a container on the left side and container on the right side. And the right side container is scaled out. So you have 20 instances. The left one needs to know how to talk to these 20 instances. So you need any kind of load balancing and service discovery. Then you need some kind of self-healing or monitoring of your containers. So your system needs to understand when an application is up, when an application crashed, to make sure that traffic is only routed to that instances who are up and looking fine. And if an instance has an issue, a container has an issue, the system needs to know what to do, or at least to kill it and to restart it, or start a new instance. And then we have some advanced topics, like you might want to manage your secrets or your configurations, and you might have stateful applications. So you want any kind of storage management and so on. So with this, you might get some idea what you might need when you're running container in production. And yeah, you might need to get some more data. So I think my camera just had an issue. Let me check. Sorry for that. Okay. Sorry. Oh, okay, I'm back. Sorry for this. Okay, so let's continue. So why do we need, or what tool can us help to run container production? So, of course, Kubernetes. So it's part of my title and my talk. So yeah, it's basically about Kubernetes. And what is Kubernetes? Kubernetes is an open source tool which helps you to automate, scale, and manage your container workload. And doing so with a declarative approach. So you're not only telling the system, please, you're telling the system, please run X instances of my application. So let's say, please run 10 applications. And then Kubernetes is doing that. So you're not defining, hey, Kubernetes, please do this and that to get to your 10 instances. You're just telling Kubernetes, please start 10 instances and make sure that those instances are running all the time. So this is a nice example. I said so. Let's say I say in Kubernetes, hey, I would like to run my app and I would like to have 3 different instances. And then Kubernetes will say, hey, okay, I will now start 3 instances and ensure that they're always up and running. And then some minutes later, Kubernetes is saying, oh, an instance died. So I will start another instance because you would like to have 3 running and now you only have 2. So I will start up another one. And this is completely done without interacting of myself. So it's really Kubernetes making sure that those 3 instances I would like to run are up and running all time, or at least nearly all time. Yeah, so some facts on Kubernetes. Kubernetes is a Greek word, so it's helmsman or captain, which is pretty nice for me. So I think it matches pretty good. Then it was introduced by Google in June 2014. So it's somehow old, at least for the cloud native world. It's pretty old so far. It's hosted by the Cloud Native Computing Foundation and was introduced by Google. But 6 weeks after the project was open sourced, Microsoft, IBM, Red Hat, Docker, and some other big players joined shortly after the first release, and then many different companies as well as humans are contributing to the project. So it's one of the biggest open source projects out there. Yeah, Kubernetes was not the first container management tool Google built. So they built two other ones, Borg and Omega, but those are only running within Google to manage Google's workload. So Google Search and the other Google services. And yeah, with Kubernetes, Google decided to not only build a tool for Google itself, but also for the world out there. And this is why they open sourced or contributed to Kubernetes to the open source community. And yeah, de facto Kubernetes is the container orchestration tool out there. There are some other ones, but mostly Kubernetes is used at the moment. So let's get me a small introduction about how Kubernetes works, so that you understand the basics of Kubernetes. So when we talk about Kubernetes and Kubernetes workload, we do not talk about containers. So the smallest instance we're talking about, when we talk about Kubernetes, it's called a pod. And this is because a pod, or the smallest instance in Kubernetes, which is called pod, can run multiple stuff. So you have the option to really put in the layer your application needs and to make sure that the dependencies are met. And then we have scalability. This is basically an option to scale out containers. Of course, the application itself needs to support this or needs to allow this. But if the application allows it, you can easily scale out your applications on one node or on multiple nodes because of having the isolation between the instances. And the first and last thing is immutability, which basically means every time a container starts, it starts from the container image you provide. So every instance of this process or of this container is looking the same all the time. So you're defining your Docker container or your Docker image with a Docker file, you're putting in all the dependencies, and with this, you are able to have immutable and same looking container instance every time you're starting a container. And with this, you can also restart a container without losing any changes and so on, or at least losing any dependencies, because you're starting a new instance and it will look the same. Okay, but with container, we are not yet production ready. So there are some things we will need to run containers in productions, and with just running containers or just using Docker as we know it will not provide with us. So some of them are around managing, around scaling, and around monitoring your applications, and yeah, to better run them in production. So examples, yeah, you maybe would like to scale containers across multiple nodes. So thinking of you're running Docker or Docker Compose, you're limited to one node. So if this node doesn't allow you to provide you with enough compute or resources, you need to scale out by adding more nodes. Or if you would like to have you're sure that your instance or your container is running all the time, you might need to add multiple nodes to have any kind of high availability. So with just using Docker plain or Docker Compose, this wouldn't work. Then you need somehow service discovery and load balancing. Thinking about you're scaling out your application, you're running 5 instances, 10 instances, 20 instances of your application. You need a piece which helps you to do load balancing between those instances. And you also need a piece which allows you to talk between the services. So think about you have a container on the left side and container on the right side. And the right side container is scaled out. So you have 20 instances. The left one needs to know how to talk to these 20 instances. So you need any kind of load balancing and service discovery. Then you need some kind of self-healing or monitoring of your containers. So your system needs to understand when an application is up, when an application crashed, to make sure that traffic is only routed to that instances who are up and looking fine. And if an instance has an issue, a container has an issue, the system needs to know what to do, or at least to kill it and to restart it, or start a new instance. And then we have some advanced topics, like you might want to manage your secrets or your configurations, and you might have stateful applications. So you want any kind of storage management and so on. So with this, you might get some idea what you might need when you're running container in production. And yeah, you might need to get some more data. So I think my camera just had an issue. Let me check. Sorry for that. Okay. Sorry. Oh, okay, I'm back. Sorry for this. Okay, so let's continue. So why do we need, or what tool can us help to run container production? So of course, Kubernetes, so it's part of my title and my talk. So yeah, it's basically about Kubernetes. And what is Kubernetes? Kubernetes is an open source tool which helps you to automate, scale, and manage your container workload. And doing so with a declarative approach. So you're not only telling the system, please, so you're telling the system, please run X instances of my applications, or let's say, please run 10 applications. And then Kubernetes is doing that. So you're not defining, hey, Kubernetes, please do this and that to get to your 10 instances. You're just telling Kubernetes, please start 10 instances and make sure that those instances are running all the time. So this is a nice example. I said so. Let's say I say in Kubernetes, hey, I would like to run my app and I would like to have 3 different instances. And then Kubernetes will say, hey, okay, I will now start 3 instances and ensure that they're always up and running. And then some minutes later, Kubernetes is saying, oh, an instance died. So I will start another instance because you would like to have 3 running and now you only have 2. So I will start up another one. And this is completely done without interacting of myself. So it's really Kubernetes making sure that those 3 instances I would like to run are up and running all time, or at least nearly all time. Yeah, so some facts on Kubernetes. Kubernetes is a Greek word, so it's helmsman or captain, which is pretty nice for me. So I think it matches pretty good. Then it was introduced by Google in June 2014, so it's somehow old, at least for the cloud native world. It's pretty old so far. It's hosted by the Cloud Native Computing Foundation and was introduced by Google. But 6 weeks after the project was open sourced, Microsoft, IBM, Red Hat, Docker, and other big players joined shortly after the first release, and then many different companies as well as humans are contributing to the project. So it's one of the biggest projects, open source projects out there. Yeah, Kubernetes was not the first container management tool Google built. So they built 2 other ones, Borg and Omega, but those are only running within Google to manage Google's workload. So Google Search and other Google services. And yeah, with Kubernetes, Google decided to not only build a tool for Google itself, but also for the world out there. And this is why they open sourced or contributed to Kubernetes to the open source community. And yeah, de facto Kubernetes is the container orchestration tool out there. There are some other ones, but mostly Kubernetes is used at the moment. So let's get me a small introduction about how Kubernetes works, so that you understand the basics of Kubernetes. So when we talk about Kubernetes and Kubernetes workload, we do not talk about containers. So the smallest instance we're talking about, when we talk about Kubernetes, it's called a pod. And this is because a pod, or the smallest instance in Kubernetes, which is called pod, can run multiple containers. Also runs multiple containers most of the time. So let me give you some more details. So this one here is a pod. We have in the middle our container, which is the container version or instance we would like to run. So let's say we have a Node.js application, .NET Core application. The application is part of this container in the middle. But then we might have, or basically we'll need networking to work with this container. So we might get traffic to the container, or the container would like to talk with another container in your cluster, so we need any kind of network layer. And the network layer in this pod is also based on a container. So the network layer on the middle is also a container. So with this, when we start our application, our containerized application in the pod, we at least get two containers, one hosting our application and the other one providing the network interface. So why is this in two containers? Especially because you can run some more or other containers within the pod next to your main process. So on the left, we have a container called init container, and the init container can be used to do anything before the main container gets started. So let's say running scripts which provide some kind of environment configuration, or a script which creates tables in the database. So anything you need for the main process, but you don't like to have it in the container or running in the container of the main process. You can put it into an init container, and an init container makes sure that the init container finished successfully before the main process gets started. Then on the other side, we have so-called sidecar containers. Sidecar containers are containers which runs next to your main process. So not like init container, which run before your main process gets started. Sidecar containers run along with your main process. And this helps you to do anything like routing. So if you like to put in proxy in front of your applications, or would like to collect metrics or do log management, you might think about collecting the logs of the main process in the sidecar and then forwarding to your main monitoring solution. Or let's say you're using a service mesh like Istio, you will need a managed proxy next to your application, and most implementations are using sidecar for this. So they're redirecting the traffic to not route to the container directly, but to route through the sidecar container to the main process. So with that, you can run anything next to your main process. Once again, everything you would like to have in your main process container, but you somehow need to run it next to it. So if you would just create a pod, which you can do, Kubernetes wouldn't make sure that this pod is running all the time. Because of this, we have some other kinds of resources in our Kubernetes cluster. So here in the middle, we do have our pod, which consists out of one or multiple containers. And then we have something which is called replica set. So a replica set is a resource where I define how many instances of my pod I would like to run. So in this case, if I would like to scale up my application, and if so, how much instances should be created. So in this definition file, I will show it to you later, it's basically saying, hey, I would like to have an instance running, or I would like to have 5 instances running based on this container image. And then Kubernetes will make sure that this is met, so that 5 instances of the container get started. But it's not the replica set resource itself, it's a controller, a so-called controller. There are multiple controllers in our Kubernetes cluster, and the controller, let's pick one. So we might have talk about the replica set controller. So we have a controller which just listen to our resources, and every time a change or a replica set resources is created, this controller is doing something. In case of the replica set controller, it just creates the pod resources. So if we define we would like to have 5 instances, the replica controller, listen to the replica set resources, would then create 5 pod instances. So And also the replica controller would make sure that 5 instances are running. So if one pod gets killed and only 4 are running, the replica controller knows that only 4 instances are running because the metrics get forwarded. And I will show you in detail later. So the replica controller makes sure that another instance or another pod resources is being created. Okay, so with that, we can make sure that the 5 instances we would like to run are up and running. So basically everything we need. But we have another resources, and it's called the deployment resource. It's basically the resource you will most of the time will work with. So the deployment resource is just providing another abstraction layer and basically allow us the same information. So or provide the same information. We can provide a container and we can provide how many replicas we would like to run or instances we would like to run. But under the hood, the deployment allows us to upgrade our service. So let's think about your 5 instances running in your cluster and you would like to update your application. So it basically would like to roll out a new container image version, a new tag. You're changing your deployment definition, provide a new tag, and apply this into your Kubernetes cluster. The deployment will make sure that another replica set is created next to the replica set already running in our Kubernetes cluster. And in this new replica set, a new container or new pod with the new image gets started. And then, based on your definition, the new pods get scaled out and the old pods in the replica set get scaled down. With this, you have a seamless update, and you can define how this should all work. But in the default, you have a seamless update. The new replica set gets scaled out, and the old replica set gets scaled down. And with this, you have all the time instances running, and you have a smooth update of your application. And this is why the deployment replica or the deployment resources that we normally define. So we define a deployment, and then the deployment decides based once again on controllers if a replica set needs to be updated or a new one needs to be created, and the replica set then makes sure that the replica count is met by pod definitions. And then there's a kind of software I will talk about later, which actually starts the actual process that runs the actual containers. So with this, we have our workload running in Kubernetes. So we have our pod running, and we can make sure that it's running all the time. If the container or the process gets crashed, a new instance gets started in just some seconds. We can scale out and so on. But we might need to talk to a different application into a cluster. So let's say pod A might want to talk with pod B, and there's some services. It's called, or there's a service which is basically called cluster IP service, which handles this. So with this, a pod, let's say pod A, can talk to pod B, basically through a defined DNS entry. So let's say we have the pods below are called pod B. We can then create a service B and tell the service, hey, all these pods with that definition should get the traffic forwarded. And then our pod A can talk to service B, and service B can route the traffic to one of the pod from the B pods. But the service also knows which of those pods is up and running and does not have any issues. So there are health checks, which you can define. And with this health checks, the service can make sure to only route traffic to an instance which is actually working. So with this, you have the internal communication done, and your services can communicate within the cluster. But then you might have also would like to expose your services to make an external application or a user, giving user access to your microservice running Kubernetes. So there are different kind of services you can use. So first of all, we talk about the NodePort service, which actually opens up the nodes as a part of its name and provide an entry point for external persons or services. So let's talk, we have 3 different nodes in this example, and on every node, a port, normally a high port, because of security reasons, get open. And if traffic or a request gets sent to this high port, the Kubernetes cluster routes this traffic to the internal cluster IP service we talked about some minutes ago. And then once again, the service is redirecting the traffic to one of the pod instances, which is pretty cool. This port gets opened on every node in our cluster. So the person or the service contacting our application does not know on which node the application is running. So it's just talk to any node in the cluster, and then the request is routed internally. But it's still not the best option because we use high ports. We somehow have multiple entry points, so we need to think about load balancing, traffic management, and so on. So it's not a nice option to export and service to an user itself. So we need something better. And there's something better. And basically, we, most of the time, will also act with this kind of service, the load balancer service. But the load balancer service is basically the same as the NodePort service. So let's step back. We have on every node a port opened, which is basically just IP tables, and the traffic gets forwarded. With the load balancer service, it's basically the same. But on top of exposing the ports on every node, we get a load balancer automatically added. So we're talking about Azure today. So in this case, the Kubernetes cluster will talk to Azure and will request the load balancer from Azure and will automatically configure this load balancer at a public IP or a private IP and define the routing to route all requests to our Kubernetes nodes, which to the NodePort, to the high port, which then route the traffic to our service in our pod. So it's basically a NodePort service with an automated way to put in a load balancer. And on this load balancer, then the user or the external service can just talk to one IP address, and the load balancer knows where to route this traffic. And this is completely automated. So Kubernetes will talk to the to the Azure resources and will request a load balancer for you, will configure it automatically. There's another one or another service which is basically not a service, but it's a pretty nice implementation. It's called Ingress, and Ingress is an option to define Ingress resources in your Kubernetes cluster, and those Ingress resources can be used to define how a request gets routed into our cluster. So options like described here, you can define different full qualified domain name and route them to service A. You can add a context route and route this one to another service, and you can also define any other kind of details and route them to any other service. So you have somehow an option to better define which URL, which context route get routed to which kind of service in your Kubernetes cluster. But you're only defining this one in a with a resource definition, so like creating a pod or a service. In the back end, to get this working, there's an Ingress controller running, and the Ingress controller is just any kind of HTTP server or proxy, understanding those configurations and implementing those configurations. So we're defining an Ingress application, and the Ingress controller is then rewriting these configurations into the configuration of your chosen HTTP proxy. Normally it's an Nginx, but you can also use any kind of other proxies, Azure proxy, Envoy, and so on. So terrific. There's plenty options out there which are supporting this Ingress definitions. And with this, you have granular access and can define which service gets routed or which FQDN gets routed to which service. On the other hand, you can also configure TLS. So you can configure TLS termination inside of your cluster. You can manage the TLS certificates inside your cluster with Kubernetes resources, and you have a nice way to configure all your traffic routing with that. But it's basically not on service. Also, Ingress is based on a load balancer service, so also this managed proxy, which is used to enable Ingress, is also exposed as a load balancer service because this one needs to be available from outside the cluster. Yeah, so a big picture at the end, how everything is working. Here on the upper part, we have the master or the control plane. So everything managing our Kubernetes cluster. On the left side, we have our dev operations guy talking to the API server. So the API server, this kind of tool or process we are talking to, or nearly everyone in the Kubernetes cluster is talking to. So when we create resources, we're talking to the API server. Then we have those controller manager, as I said, replica controller manager, deployment controller manager, acting on those resources in the API server. We have the scheduler. The scheduler is the process which decides on which node in our Kubernetes cluster a pod gets scheduled. Based on the matrix of the cluster, it defines the information, put it back into the pod resource, and just write the information back into the API server. The etcd is just a key value database where the API server persists its state. And then on the lower part, we have the actually worker nodes, which are hosting the workload, and there the pods are actually running. But we have the other components. We have the kubelet, and the kubelet, that part I talked about earlier, which access or also listen to the API server and waiting for new pod resources. And every time there is a pod resources with the node definition the kubelet is running on, it's starting an instances of this pod on the node. CAdvisor just sends back metrics and other information about the node into the API server to allow scheduler to decide which node should be used for a new scheduled pod. And then we have the kubeproxy, which is just the external part of a node which gets the actual user traffic from outside the cluster. Yeah, I also talked about the resource definition. So you can define them in YAML or JSON. Just an example on the right. As I already mentioned, we have a kind of deployment here where we define our replicas. We would then define our container, which we like to run. In this case, is based on the Nginx image or the latest tag. And this would then start one instance and make sure that this instance is running all the time. You then need to path this configuration to the API server. This can be done via multiple clients. I will have some information on the next slide on this, and then gets verified and processed by the API server. Working with Kubernetes with different options. I think the most common one is kubectl. It's a command line tool available nearly any platform, so it's available on Windows, Mac OS, on Linux. And kubectl allows you to work with the Kubernetes cluster. So you can list or get resources, you can create and delete resources, and you can access any kind of API resources and details using kubectl. You can also attach to containers, so allow you to attach inside the container and debugging the container or checking some things in the container, so basically only for troubleshooting purposes. And you have an availability to port forward your into your container, so basically to make the process in your container available on your local machine on localhost. which can also be used for debugging purposes or for development purposes. And kubectl is completely extendable, so there are different plugins out there. You can write your own plugins and extend kubectl. On the other hand, you have a dashboard or multiple dashboards. There's the Kubernetes dashboard. There are also some third-party ones, which basically provide you the same information on the same details and same functionality, but with a nice browser-based UI. And if you already work with Kubernetes, you might also know some tools like Helm or Customize, which can help you to actually deploy your applications into your cluster on a production-readier manner than just with using kubectl. Okay, so this was about Kubernetes basics. So let me just check for Q&A. For this part of my presentation, we have one question: when routing traffic to a pod, is it round robin, or can I also configure session persistence, so like HTTP clients ending up at the same pod for every HTTP request? So we have multiple options to define the routing with plain Kubernetes options. So round robin is the basic one, but you can also define other ones. If you have really advanced functionality, you can use the service mesh example to better route this traffic or to route to different version of your applications. So if you like to have, I don't know, 20% to version 2 and 80% to version 1, that kind of routing options. You can do it with Kubernetes basic versions, but I think there are other use cases where also a service mesh can help. But I hope this one answers your questions, but when not, just let me know. Okay, so then heading over to container services on Azure. So what you can do with Azure. So Azure provides you with a container registry, so a place where you can store your container images. It's fully managed and fully scalable. So it's a managed service. You don't need to update it on your own. It's fully managed. It's completely integrated with Azure AD. So you can authenticate with your Azure user with the Azure credentials. You have granular role-based access control definition. So you can define who is allowed to push an image, who is allowed to pull an image, who is allowed to delete images, retake images, and so on. Which is also a nice feature is that the Azure Container Registry and the Azure CLI together allow you to build containers without having any kind of local dependencies. So you can use the Azure CLI like the Docker CLI and doing a Docker build, blah, 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 just with the Azure CLI. And this will then upload your code as well as a Docker file into Azure Container Registry, and Azure Container Registry will build this image for you. So no need to build your images locally or on your CI/CD runner. You can just let Azure Container Registry build those images for you. The Container Registry also supports OCI images, which basically allow you to store other things besides just container images. So with OCI images, you can also store your Helm charts and things like this into your registry, version them, text them, and just use your container registry as an artifact store. Pricing is based on service tiers and usage. So basically, if you would like to have any kind of advanced features, and I will show you some in a second, and how much storage do you need, how much build time you need if you would like to use the container build option. And it also integrates with Azure DevOps, of course, and also GitHub Actions to use the container registry to build your images. So some advanced features, you can also integrate container image scanning. So the premium tier version of container registry support this, but you can also add some third-party tools like Aqua or any other solutions out there to scan your images before those get published in a container registry, and therefore before they can be deployed or run in your Kubernetes cluster. Other nice feature is geo-replication. So if you have a geo-replicated environment, maybe running multiple Kubernetes cluster in different data centers, or let's say you have one running in US and one running in Europe, you can deploy a container registry next to each of the Kubernetes cluster with geo-replication to make sure that the container gets started pretty fast, so that the image does not need to be downloaded from a different part of the world, so that is next to your Kubernetes cluster and can download it and start it then pretty quickly. And this is completely abstracted from your side, so you're just building a container images, and Azure will make sure that the container images are pushed to the different geo-replications. So next to Azure Container Registry, we have Azure Container Instances, ACI, which is a, let's say, serverless option to run containers. So with this service, you're just thinking about your container images, telling Azure, hey, I would like to run this container image, and that is it. So you don't need to care about the underlying OS. You don't need to care about how you could scale this out. You don't need to care about VM sizes and stuff like this. So it's just defining an image, defining a tag, defining the resources the container should have, and starting it and running it. So this works with Linux as well as Windows and GPU workload, and it's a pretty nice service to use with event-driven applications or data processing jobs. So anything which does not need to run all the time, so just need to do one job and then stops again, or doing jobs every night on a scheduled basis. So it's pretty nice for those event-driven or data processing jobs. And which is also a pretty nice feature, that you can integrate Azure Container Instances with your Kubernetes cluster, which then allows you to really fast scale out or to isolate your compute. But I will have a detailed slide, detailed picture on this later. But it's a pretty nice option to integrate Azure Container Instances with AKS. Yeah, once again, Azure Container Instances is pay-as-you-go, so it's based on the CPU and memory your containers need, or you define, can of course define the limits, and then you pay it as you go. In general, Azure Container Instances are a little bit more expensive, so I really should only use for applications which do not run 24/7. Of course, can use it therefore, but then it would be more expensive than using other services out there. Yeah, with that, we are coming to Azure Kubernetes Service, which is a fully managed Kubernetes cluster, so we don't need to care about any kind of updating your Kubernetes version, making sure that your control plane is high available or anything like this. So it's fully managed. You don't need to think about any kind or anything related to the controller plane. It's scalable and secure by default. So it's high available. You can scale out your node as you need them. You can auto-scale your node. You can manual scale your node. All the security best practices are mostly enabled by default. So you need really to opt out if you would like to disable security feature, which is good for new people starting with Kubernetes, that they have a quite good security level. It runs Linux, Windows workload, and also CPU-based workload. So if you're anything related to CPU workload, you can also run it on Azure Kubernetes Service. And it's pretty nice integrated with Visual Studio Code or also Azure Dev Spaces, which is a nice way to develop on Kubernetes, or at least move some of your development workload or dependencies into your Kubernetes cluster. Pricing is also based on compute. So you need to define your VM sizes for your worker nodes. There can be different sizes. So you can define different node pools with different VM sizes. And then you just pay for those virtual machines, the normal virtual machine price, and the whole control plane, or the master part I showed you in the big picture, is free of charge. So you don't need to pay for anything there. You're just paying the compute which you need on your worker side. So only the virtual machine sizes you define, you need to pay. Everything else is free of charge. Yeah, so AKS of course integrates perfectly with the other Azure services. So for example, Azure Monitor, which can help you with your monitoring, but I have a slide on this later, as well as Azure Policies for governance topics, Azure Files, Azure Disk for persistent storage of your applications if you have need them, Azure AD, Active Directory for authentication, authorization into your cluster. It integrates with the virtual network. You can add an Azure Application Gateway and hire your application include security. You can manage your secrets with Azure Key Vault instead of using the not really secure secrets version of Kubernetes. It's fully integrated with Azure DevOps for CI/CD, and you also get some nice administration options in the Azure portal. So if you don't like to use CLI, or just would like to scroll through some logs or get some information on a pod, you also find a nice integration in the Azure portal. And this is only an overview. Let me deep dive in some examples. So with Azure Kubernetes Service, you're able to integrate your Azure Active Directory and use it for authentication, authorization. And this is completely integrated. So you can decide this Azure AD user or this Azure AD group is allowed to create deployments, is allowed to access this kind of namespace and so on. So you can really define which the person or the group is allowed to do. And then the developer or the user uses kubectl, access a cluster, and then the URL pops up with a secret, and you just copy the secret, open the browser, put the secret in, and then you get the login screen. You can log in with your Azure Active Directory credentials, which then happens that the Azure Active Directory will provide you with a token. And with this token, you can seamless authenticate against the Azure Kubernetes Service. And with that, you are done, you are logged in, and all the authorization steps you define in a Kubernetes cluster will start to work. So then you have cluster autoscaler and virtual node feature. So cluster autoscaler allows you to scale based on your workload. So if your workload gets scaled out because of you're getting a peak or anything like this, Kubernetes or Azure Kubernetes Service is able, if you're able to feature, is allowed to scale out the virtual machines to provide you with more compute to actually run your different pods. This just works in this way that if a pod isn't able to get started because of compute is missing, this pod is not scaled or is not started, so it's in a pending state. And on this, the autoscaler acts. So if a container is in pending state because of missing resources, CPU or memory, the autoscaler will go ahead and add a second node into the cluster, or provision a second node, which basically is creating a virtual machine and adding the virtual machine into the cluster. And then when the virtual machine is up and integrated, the pod gets scheduled on this new node and the application of the container gets started. So as I already mentioned, this option, the cluster autoscaler, is used to create new virtual machines and put the virtual machines in the scale set of the node pool, which is pretty nice, but might be not enough if you need to scale out pretty fast. So if you need to scale out in seconds and not minutes, you might need to think about another solution. And this is the virtual node based on Azure Container Instances. So with Azure Container Instances, you have option to integrate Azure Container Instances with Azure Kubernetes Service using that virtual node function. And with this, your Kubernetes cluster is able to put workload into the serverless Azure Container Instances service, and therefore can scale out just in seconds. So it's nice if you need really scale out pretty fast. On the other hand, you can also use container instances to isolate some kind of workload. So if you have some workload which is pretty needs pretty high resources, memory or CPU, and you would like to run this service within your Kubernetes cluster or on your specific Kubernetes nodes, you can just move it to Azure Container Instances and isolate it. Of course, there's also the need to maybe run private clusters in Kubernetes. So basically running a Kubernetes cluster, but only exposing it into your personal private network and subnets. This is possible with Azure Kubernetes Service. So on first thing, the API server gets exposed into an internal subnet, not with an external IP, which is the basic setting. With it, the API server or API endpoint is only available within your subnet. And on the other hand, you can also expose your services using an internal load balancer, which not get an external IP address, but it's a public IP address, but it gets an IP address from an internal subnet of your configuration, and therefore uses the private load balancer. And with this, your services get exposed only internally in your virtual network, in your Azure virtual network. Of course, this feature is also available for other services. Some of them are still in preview, but should be available pretty soon. So we have the service available for Container Registry to allow your containers or to also expose your containers or your Container Registry on the internal, and also for any kind of storage services. So Cosmos DB, storage accounts, blob storage, and so on. Also interesting if you have any kind of stateful applications. Yes, then we have Azure Monitor with the Container Insights solution, which allows you to not only monitor the Kubernetes cluster nodes itself, but also monitor your Kubernetes workloads or your container. It also allows you to forward any kind of Prometheus metrics if your application exposes them using the custom source option below. And you can also put in any other kind of Azure resources, any other kind of managed services, and so on. Azure Monitor can store metrics and log data based on log analytics. And with this, you can then get insights of your applications, visualize them with dashboards or Power BI or anything like this, analyze them, or also put on alerting to get alerted at any kind of issue. And you can also integrate it with any kind of other solution. So you can use Event Hub to forward the data to a Elasticsearch stack or any other stack, and so on. So we can use Azure Monitor as your monitoring solution, but you can also forward the information to any other kind of monitoring solution you might need or might work with. Then pretty new feature is governance with Azure Policies. So with Azure Policies, you have the availability to define certain policies in your whole subscription. So I only would like to run certain container, certain virtual machine types. I only would like to use certain locations and so on. And now you also have the option to governance your Kubernetes cluster. So you can define things like, I only would like to allow certain container registries, or let's say the Kubernetes cluster is not allowed to start container images which are hosted on Docker Hub, or things like this. So you're able to have granular access into your Kubernetes cluster and can define certain policies for governance reasons. Pretty new feature, but it's it's available for some weeks now, I think. Then we have the Azure Key Vault integration, which is a nice solution to manage your secrets, which you may already have in your Azure Key Vault, but you can also integrate your Azure Key Vault with your Kubernetes cluster, which then allows you to inject secrets or certificates stored in your Azure Kubernetes Azure Key Vault into your workload. So with this, you can inject secrets or certificates into your container workload as you node, as file, as environment variable, and so on. And the secrets itself are then stored in the on a secure way in your Azure Kubernetes Vault, and you can also use them from different services in your Azure world, not only Kubernetes but all other services as well. And with it, they're pretty secret and stored pretty secure. The secret, the basic Kubernetes secret, is also a resource type we can use. It's not that secret, so it's basically only base 64 encoded. There are certain kind of security options in there, but it's not fully secure. So it's pretty nice to have this kind of option with the Azure Kubernetes Vault. Then there's a pretty other nice option, which is Azure Active Directory pod identity, which allows you to give access or enable your container to access certain Azure resources. So with this, you don't need to create a connection string to allow your container workload to talk with Azure Cosmos DB or any other storage option, and to handle the authentication in your code, in your application code. But with this, you can allow the container to access the Azure resources in behalf of. So we don't need to put in any kind of connection string, any kind of secrets. You basically allow the process, the container itself, accessing this Azure resources, which is pretty nice abstraction layer to not need to configure the whole secret management and connection management into your application. So you can put it out of your application code and just abstract it and configure it with your Kubernetes deployment or your application deployment into your Kubernetes cluster. This is also based on the Azure Active Directory integration and the Azure Key Vault integration. And it's based on node managed identity, which you might already know from a virtual machine-based workload. So it's a solution which is available in Azure for some time now, and now we can also use it with our containers. So with this, I would jump over to a short demo. So we're a bit limited in time. So if you have any kind of questions, please feel free to post them in the Q&A. Then I can decide if you get started with a demo or just doing Q&A. But until I don't see any questions, I will just start with the demo. So here I already created a Kubernetes cluster and a container registry up front, because I had the idea that I might be limited in time. So this, we have an AKS and Azure Container Registry. I created them with the Azure CLI. So I'll just give you some details, making this a little bit bigger. So you can use the Azure CLI and then provide AKS, create. With this, you have the option to provide the resource group. So where should the Kubernetes cluster live? You can add the name. You can add the name of the Kubernetes cluster itself. You can define the Kubernetes version, the node size. So in this case, I'm creating one node with the size B2S. I define the location, and I define how it should authenticate with Azure. In this case, I'm using a pretty new feature, which is managed identity. And then there's a managed identity created with the Kubernetes cluster we'll use to talk to the Azure resources to get storage, disk storage, or any other kind of storage, or the load balancer to get access from outside. So just need to change the name because we already have this one. So let's say version 2, and then the Kubernetes gets created. This will take some time. So we do not have the time to wait for it. So I will open up a second window, but it's now running and will get created in some minutes. Same again for the Azure Container Registry. This time it's ACR create, and with some less options. Once again, I can provide a resource group and a name. In this case, I just added a random part to the name because the name needs to be unique. I define a location and the service title. And this one should create pretty fast. Once again, I need to change the name. So it should only take some seconds. Oh, okay. The name is already used. Perfect. So put in some. So with that, the registry already got created. So if we do a refresh, oh, we see the Kubernetes service, which is still created, and we should see in just some seconds our ACL. Okay, so it's maybe some cache. Okay, so no questions so far? Okay, so with that, I would have some further steps, but I only have 3 minutes left, so I would come back and yeah. So, do you have any questions? Any further to discuss? No. Okay, someone raised his hand. Oh, do you have any kind of questions, or please use Q&A? Okay, if not, I'm happy to move over or move back to Dennis. I will be